Hi everyone. My name is Shashwin, and in this section, I'll be presenting our square test of independence, which investigates whether there is a relationship between parental education level and students' tutoring status. First, let's look at the objective of this analysis. The purpose of this test is to determine whether a student's likelihood of receiving tutoring is associated with the education level of their parents. In simpler terms, we want to know whether students whose parents have different education levels are more or less likely to receive tutoring. So, the two variables used in the analysis are parental education level and tutoring status. So, parental education level consists of five categories: non, high school, some college, bachelor, and higher, whereas tutoring status has two categories, which are yes and no. Since both variables are categorical variables, the chi-square test of independence is the most appropriate statistical test to use. Next are the hypothesis statement. The null hypothesis states that parental education level and tutoring status are independent. This means there is no association between a parent's education level and whether a student receives tutoring. Whereas the alternative hypothesis states that parental education level and tutoring status are not independent. In other words, there is an association between the two variables. Now let's examine the observed frequencies. From our contingency table, we collected data from 2,392 students. For students whose parents had no formal education, 167 students did not receive tutoring, while 76 students received tutoring. For high school students, there were 504 students. For parents who had high school, there were 504 students without tutoring and 224 with tutoring. For parents with some college experience, there were 653 students without tutoring and 281 students with tutoring. For parents with bachelor's degree, there were 261 students without tutoring and 106 students with tutoring. Finally, for parents with higher education, there were 86 students without tutoring and 34 students with tutoring. These observed frequencies represent the actual data collected from the students. Next, we calculated the expected frequencies under the assumption that parental education level and tutoring status are independent. The expected values were calculated using the formula expected frequency equals row total multiplied by column total divided by the grand total. For example, the expected number of students without tutoring whose parents had no formal education was 169.75, while the expected number with tutoring was 73.25. Similarly, expected frequencies were calculated for all the remaining categories. Oops. Sorry. One important assumption of the chi-square test is that every expected frequencies must be at least 5. In our analysis, the smallest expected frequency was 36.17, which is much greater than 5. Therefore, this assumption is satisfied and the chi-square test is valid for this dataset. Now let's move on to the statistical test. Using RStudio, we obtained a chi-square test statistics of 0.7485. The degrees of freedom are calculated using the formula rows minus 1 multiplied by columns minus 1. Since we have 5 rows and 2 columns, the degrees of freedom are 5 minus 1 multiplied by 2 minus 1, which is equals to 4. Using a significance level of 0.05 and 4 degrees of freedom, the critical value from the chi-square distribution table is 9.4877. Our decision rule is simple. If the chi-square statistics is greater than 9.4877, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Since our calculated chi-square statistics is 0.7485, which is much smaller than the 9.4877, it falls inside the non-rejection region. In addition, the p-value is 0.9452, which is much larger than the significance level of 0.05. Therefore, using both the critical value method and the p-value method, we fail to reject the null hypothesis. So here's the summary of our results. The chi-square statistics is 0.7485, the degree of freedom of 4, the critical value is 9.4877, the p-value is 0.9452, and our final decision is to fail to reject the null hypothesis. Now let's look at the visualization. The group bar chart shows the distribution of students who received tutoring and those who did not across all five parental education levels. We can see that the proportions are very similar in every category. The chi-square distribution graph also shows that our test statistics 0.7485 lies far to the left of the critical value 9.4877, which confirms that it is inside the non-rejection region, which is here. Now finally, let's interpret our findings. Because the chi-square statistics is very small and the p-value is much larger than 0.05, there is insufficient evidence to conclude that parental education level influence whether students receive tutoring. This means that in this data set, students whose parents have higher education are not significantly more likely to receive tutoring than students whose parents have lower education levels. In conclusion, our analysis found no statistically significant association between parental education level and tutoring status. Sorry. This suggests that students' decision to receive tutoring are likely influenced by other factors rather than their parents' education level. So, thank you. That concludes my presentation for section 3.4.